All right, welcome back, everybody. Today is day two of the guided application program. Thank you, all of you guys, for showing up today. Yesterday, we covered the Python data types methods, but unfortunately, we weren't able to get through the entirety of it. So we're going to go ahead and pick up from where we left off and then move on into lesson two. I believe yesterday we ended somewhere around replace. So we'll pick up from there. We were talking about the built-in methods that come with Python. We'll continue with these. The next one we had here was the split method, and this is a very powerful method which you'll probably find yourself using a lot, especially starting off during your programming journey. We have here a string uh, of a date, right? A date in string format. And then we see here that they invoke the split method on the string variable. And within this method, they're passing in a forward slash, right? And what this is going to let your code know is, hey, I want you to grab this string, right? That's saved into the date underscore str variable. And I want you to split it at every point that you find a forward slash, right? And what the split method does, it returns to you the content of that string in the form of a list, right? So it looks through the string, it finds the first forward slash, and it takes everything before that and everything afterwards and splits it, right? It adds the first part into a list and it continues moving forward. Notice that it doesn't add the forward slash. It splits it there, but does not include it, right? After that, it finds a 14 and then a forward slash. So it splits the 14 off of it, adds it into the list, removes the forward slash, and continues moving forward. It does not find another forward slash, so it grabs whatever was left over and adds it into this list, right? And then we go ahead and we send the split date back, and we get the response, right? So the expected result. So split's a great way to kind of split up a string, maybe like at spaces, right? So we had something like my name is equal to, let's say, Roger de la Garza. Um, I could, split name is equal to my name dot split, and I could split it at every space. Notice that I put a space here, and the split name would print out my first and my last name. So it's a great way to split up your string at certain locations, specifically at spaces. All right, that covers the split method. The next one is join. So we talked about how to split a string, but what if after we split it, we want to move it back into a to where it was originally or in a new way, right? And if they're using the same variable here, split date that was declared above, and using that, they're invoking the dot join method. And now it looks a little funny here, so keep that in mind. It does not work how the other traditional methods work. It takes a string, right? And then that's the string that's going to use to join everything else with it, right? So essentially, what this is saying is, hey, I want you to uh, join everything that's within the split date using the open and close quotation marks. And there's nothing between these quotation marks. So what's probably going to happen is going to join them all together with nothing specified in here. But if you add something within the quotation marks, you'll see that it now rejoins them using that forward slash. So we're able to join stuff together either with nothing or specify something between it. And once again, it grabs the items within the string. You use the string and invoke the dot join method. And what do you want to join onto all this? Well, the split date list, right? This has to be essentially a list of different items, right? It's pretty much just the opposite of split. That's your join. So two ways of doing it. If you want to split it up or join these together, that's how you would reformat your string. Do I have any questions on the split or the join method? before we move on? All right. Here's some other methods. These are also very powerful as well. We have the is alpha, and alpha stands for alphanumeric, right? What this allows you to do is it allows you to check if a string is actually a character that is in the alphabet, right? So check if all characters in a string are alphabetic letters. Uh, so used for validating input that should contain only letters. Think of, you know, if your password should contain any numbers or whatever, you would use something like this. It's alpha to check whatever input is being given to you is actually within, the alphabet. So we have here the this is my string saved into the my string variable, and they call or invoke the is alpha method on it, and it prints out true, right? Notice that it is a conditional, so it will return to you true or false. True or false. And same thing can be said with the following method, which is the is numeric. So the same way that we were able to check if something was an alphabetic letter, we can check if something is a digit, right? Here we have a string of 1, 2, 3, and they invoke the is numeric method on it. And what it essentially does, it uses the typecast method that you guys saw yesterday uh, to check if it's able to be converted into an integer type that's a number, right? And using that, uh, it tells you true or false, right? If we were to add something like 4 right here, it would return false to us, right? Because everything within the string is not an actual number or integer. Right, same thing with the it's alpha. If we add something like a special character, we would get false because it's not an alphabetic letter. Next is alphanumeric. I guess I got this confused with the alphanumeric and alpha, right? So it's alnum will check for letters or digits. Everything in letters or digits, but not special characters. So we see here ABC 1, 2, 3, we get true, but if we add an at symbol, we get false. So if you wanted to check both numbers or letters, you can do this way. Once again, another conditional method that returns to you whether it's false or true. Next is the is lower and is upper. Notice here that we have all capital letters for ABC, 1, 2, 3, and we invoke the is letter on it, is lower, and it returns false to us. And same thing for is upper, it'll check the opposite of it. And I don't know if it's going to have an issue with, no, I shouldn't have the issue with numbers or spaces, right? So it's smart enough to be able to grab the alphabet letters and checks if they're in uppercase or lowercase. These are one or some of many of the methods you can find. Very, very useful for you guys, and probably some of the methods you guys will use during your technical assessment for your interview to come into Platoon. So definitely something to get used to and look into. If you want more of these, once again, I recommend going to W3 Schools. You can find this resource, and you can even find this link in the curriculum. We go to Python, and we can find stuff like Python strings and then string methods. And you'll find the long list of different possible methods. And like I said, those are some of all the methods that come with it. You don't have to know all of these. The ones that were just demonstrated to you guys are probably the most common ones that you will use and the most helpful ones. So there's a lot of these methods. You don't have to memorize all of them. Being a developer isn't being a computer. You'll see here that my background is actually a cheat sheet of the different methods and stuff of Python. Because just like everybody else, I'm human and I don't remember everything off the top of my head. So it is helpful to have a reference like this. So there's so much that you can do with Python and JavaScript or any language you're doing. Don't expect to memorize all of them, but I think the ones that are being demonstrated here in the curriculum are definitely some that you should probably save into your toolkit and keep in the back of your head so they're easily accessible when you guys are working with your technical assessment with Guillermo. So if any questions on any of the methods, whether the conditional ones or not conditional. Right on. I see Tristan. Yep, I agree. I had a bunch of sticky notes on the bottom of my monitor for a job interview, all that stuff. Yeah, I mean, you gotta do what you gotta do. You know what I'm saying? What you know, we're not computers. There's so much with technology, Python, JavaScript, all the different frameworks. Uh, Technology is constantly evolving. You know, they say that our technology advancements double every like 5 years. That's one of the cool things about software engineering, software development is that you never stop learning. There's always something new, new versions of everything, constantly being stuff is being outdated and things are being updated and added. So you never stop learning. All right. The next step is going to be talking about interpolated strings, right? Essentially, what an interpolated string is the ability to add a variable into your string. And we see here a small example, but let's talk about how this could be done without string interpolation. If I wanted to print out Jimmy Fallon together, what I would have to do without string interpolation would be do first name plus, let's say, an empty space plus last name. Let's go ahead and comment this out. The first name has Jimmy and the last name has Fallon, right? If I wanted to print this out in a formatted manner of what a name should look like, without string interpolation, I could do something with the plus operators, right? I grab the first name, I add the space afterwards, and then after that space, I add the last name. And by running this, I see that I get my formatted string, right? So this is like a beginner way of doing it, easy to read. You're trying to essentially grab multiple strings and add them together and format them in a manner that represents a real name. Well, there is a much more efficient and better way of doing this. That is string interpolation or an interpolated string. Let's go ahead and comment this out and uncomment this. Here we have a variable called greeting. And the way that you are going to essentially declare or start an interpolated string is by using the F letter. Let me go ahead and zoom in a little bit so you guys can see. You're going to use the F clause. And what this tells Python is, hey, like the F, I'm formatting a string here, right? So you need to be aware that there's probably going to be some variables within the string that I want you to use and apply into my string, right? The F string stands for, I believe, format. Don't quote me on that, but I believe it's formatted or format. After you invoke the F string, you're going to go ahead and open up some quotation marks, whether they're single or double quotes. And then you can proceed to format the string that you want to create. Notice that it starts off very simple. It's a very basic string. It says hello, comma, space. And then what we do here is that we add a variable into this string. And the way we do that is by using the curly brackets, right? I believe, if I remember correctly, because I'm rusty on JavaScript. For JavaScript, you would have to use like a $ and then the curly brackets to let it know it's a format string, and it would be within like your backticks. For Python, we don't use that. We use the F to let Python know this is a formatted string. And then to actually add a variable within your string, you add them within curly brackets. So what this shows is the hello string, comma, space. We add the variable, and when this runs, the Jimmy string saved into this variable takes the place of this section right here. After that, there's a space. Oops. There's a space right here between first name and last name. And then we pass in another variable called last name in here. So when this runs, last name will be replaced by the string that it holds. to give us our formatted hello Jimmy Fallon, right? So two ways of doing it. You could do it the beginner way of joining two variables together with space, or you can just create a interpolated string. Do I have any questions on interpolation? All right, we can go ahead and continue with the class. The next thing is going to be escape sequences. All right, so escape sequences allow you to include special characters in your strings, right? Think of it like this. Let's say instead of double quotes, we used single quotes. This will still run, but if we had a wording here that was showing like possession, uh, like Jimmy Fallon's, show, right? The apostrophe s showing possession. How do we add that? Hello, let's say hello. This is the Jimmy, or this is Jimmy Fallon's show, right? If we try to do something like this, we get an error. And that's because it's taking the first single apostrophe and then the second one, and it's using these to create the formatted string. This is technically the closing part of it. And now we have something else here that it doesn't recognize. Well, we use the backward slash as an escape sequence that allows you to use specific characters in your string that are normally used for syntax. And we can also do stuff like a new line or tab, or also use the double quotes, right? Let me unedit this. Here's the example with a new line. We have a variable here called multi-line, and it says this is A, and then we use the backward slash n and backward slash double quotes. What this is going to do is going to start a new line. This is allowing us to use the double quotes within this string. And why are we doing this? Well, because originally the way we started the string was by using double quotes for the start and end of it. So if we wanted to use double quotes within the string, we need to use the escape character. We use it here again, and then we start a new line here as well. And we can go ahead and run this. And we see here that it prints out this is A. Once it gets to the backward slash n, it lets it know that we're starting a new line, so it goes to the next line. We're able to use the double quotes within our string to print out multi-line. We then start a new line once again to bring us to line 3, and we print out string. We also see the tab in action. On line 2, we have tab line with a string that says this is a tab string. And we have the backslash T to let it know that, hey, the T isn't just a string T, it's a special escape sequence, and I want you to actually use this as a tab, right? And we see how it formats our string here with the tabs between the A and tab and string. Do I have any questions on the escape sequences? Awesome. Let's go ahead and move forward. The last thing that we're going to talk about is none type. And if you recall from yesterday, none is essentially just the absence of data, right? It is actually a data type, right? We see here we have type none, and it returns none type. So it is a form of a data type, but it's just saying that it's just none. It's nothing else. It's not an integer. It's not a string. It's not a float. It's none, right? There's no actual value in here, right? It does not mean 0 or an empty string. You can equate none to an empty cell in the spreadsheet. This is important because as you'll see today when we talk about functions, when you don't return a value, by default, it'll give you none. And that's not something that we want in our program, right? Usually when we write something, we're trying to receive some kind of output from our code, and receiving none doesn't really do anything for us, but it does have some uses, right? We see here that none is equivalent to 0 or an empty data structure like a list. We have print, and what this is doing is running some kind of conditional statement here where none is equal to an empty string, equal to an empty list, or equal to 0. Um, and oh, it's not equal, my bad. And we see there it returns false, right? So none is just the absent data. It does not mean anything else. It's just no actual data or no usable data that we can use. My variable is equal to none. It's not printing out my variable. Let's go ahead and print out my variable. There we go, none. Do I have any questions on the none type? All right. So to close off this lesson, if you went through the lesson yesterday or after class, you might have noticed that there were some exercises here. I created an exercise folder that I'm currently adding to it as every day goes by, because it might be a little too confusing if you just see a bunch of lines of code. So I recommend for all the exercises that you do, go through the exercise document that I create because these are a lot more simpler and very straightforward, right? So you can practice. For example, here we have like write a Python script that prints the following. And it's simple as just doing print hello Python world. And I don't have a kernel selected. There we go. Right. These are very simple exercises that you can use, especially because I understand that a lot of people probably never touch code. If you've already done some coding before, this might be a little too beginner for you. So then at that point, I would encourage to actually do the exercises first at the very end of it. But if you're one of the people that you're using this as to ensure you get from 0 to hero for your assessment, then the exercises within the exercise folder are very user friendly for you to try out, right? But that concludes lesson 1. We're gonna go ahead and move to today's actual lesson, which is conditional statements and functions. Here's a table of contents. We're gonna be talking about Booleans, comparisons, and then talk about what functions are. We saw a little bit of functions already, talking about built-in functions, but we're gonna talk about how to create our own custom-made functions and how they work. Boolean values and expressions. Booleans are essentially a way to ask your program a yes or no question, right? We have the two values, which you've kind of already seen a little bit, which is your true or false. And when we use a Boolean, we're essentially telling our program, hey, is this greater than or equal to, or does this equal to that? You're asking it to return to you a yes or no question. And the yes, it will be your true, and the no is your false, obviously, right? So it's a way of asking your program yes or no. We see here type, we pass in true. And when we run this, oh, my kernel is acting funny. It returns bool, right, which stands for Boolean. If you are familiar with JavaScript, you might be tempted to type in T lowercase. The syntax for Python is capital letters, right? So just be aware of that. If you try to add T here, you would get an issue where name true is not defined, because lowercase names are kind of reserved for variable conventions, right? Variable names. So it's thinking it's a variable, but it's not defined because it's actually not a variable. So it tells you, hey, it isn't defined. So just be aware of that when using your booleans. They have to be capitalized, especially if you've been doing JavaScript for a little bit now. You might be tempted to type in lowercase t or lowercase f. Booleans can be assigned to variables. So we see here the boolean is equal to false, and then we run the boolean and it returns false for us, right? A good example would be code is equal to false if temperature is less than, oh, let's go ahead and create a variable. If temperature, I can't spell, English is hard. Temperature is, let's say 45. If temperature is less than 50, code is equal to true, right? And then let's go ahead and print out code. And we see here that print out true, right? So we're able to use this to kind of get a yes or no response about, certain data types or variables and whatnot. It's going to come very handy whenever we start talking about if statements or while loops and even functions. So it's a way for you to receive a yes or no response from your program. We talked about true or false being capitalized. All right, see lowercase f, name false is not defined. Booleans are pretty straightforward, so I'm not going to elaborate any more on that. Does anybody have any questions about it before I move forward? All right, let's use Booleans to actually compare some stuff. So you've probably already seen some of these operators used within the previous lessons, but we're going to elaborate a little bit more on the other stuff. So you've seen greater than and less than, and that's, going back to elementary math of using the forward or backward arrows, right, to check if something is less than or greater. But we also have the ability to check if something is equal to, and that is by using the double equal signs, right? We've used the equal sign before to assign a data type to a variable, but for a comparison, we would use the double equal sign. Here we have two integers, 23 and 32. And then we have the double equal sign here. And when we run this, it's going to return false. Right? What this does, it compares these two values together and returns to you a Boolean, whether they're actually equal to each other or not. Right? If we converted this to 32 is equal to 32, it'll return to you true. So we're able to compare two different types of variables together to see if they're equal to each other. If I'm going too fast, please let me know. I am Mexican, and English is also my second language, so sometimes I might slur my words. So I do apologize. If you need me to re-explain something, or maybe I didn't explain it in an effective manner, I could try to do it in a different way that might make more sense to you. So please do not hesitate to raise your hand in the Zoom, and I'll answer any of your questions or re-explain anything that I might have not effectively explained to you guys. We can also assign comparisons to a variable. Here we have 450 is less than 350. And then whatever returns from here, it's going to be a Boolean, right? We saw that here in action when we compare 23 and 32. It's going to do the exact same thing here when we use the less than or greater than operator. This returns some kind of comparison, whether 450 is actually less than 350 or it's not. All right, so we see here 450 less than 350 assigned to Boolean underscore 1. We run this and we receive false. Next, we have two different numbers assigned to two different variables, 8 and 6. And this time, we're running if number 1, which is 8, is greater than number 2, which is 6. And this returns true. So we can check whether something is less than or greater than. Both of these will return to you some kind of comparison, whether yes or no, if it is actually what you're checking against. Membership checks, right? So membership checks are a way to see if something actually exists within a specific data, right? Is it a member of a list? Here, our example is I'm not sure what STL stands for, but a list called STL Blizzard Years. Notice that we have a range of different years from 1883 all the way to, I believe, 2021. There we go. Right. It's a huge list of different integers. And I don't think we've talked about lists, right? We talked about declaring St. Louis. Oh, really? I didn't know that, Joshua. Thank you. Or are you guessing? So yeah, so we talked about declaring strings by using the quotation marks. To declare a list, we use the square brackets. So this has a list of different integers. And then what we do here is we check if 2017 is in STL Blizzard years, right? And this returns to you a Boolean as well, right? What's happening here is it's going to the list and it's checking every individual integer within here with the 2017 to see if it actually exists within this list, right? It's conducting a membership check. Is 2017 a member of the Blizzard year list variable? And then we see here the Boolean that returns to us, it says false. If we scroll through the list, we see here that we have 2015, but we don't have 16 or 17, and it jumps to 2018, right? So that's a quick way to check if something is even within a list without having to scroll through all your data. A little bit out of scope, just know that that's not the most efficient way to store a bunch of data like this in a list to see if it's in there, because they would have to iterate through every single item in here to check if it's within the list or not. But you'll learn that more as you go through your code. So 2017 in Blizzard years returns false to us. If we do 2018 in STL Blizzard years, you see that this will return true to us, because 2018 was a member of the Blizzard years list variable. All right, so we talked about in. I don't think we did not in. If we add not before the in, it'll do the complete opposite, right? We checked if 2017 was in Blizzard years, but if we say not in, it's going to return true to us, right? Because what we're doing is checking if it does not exist within this list, and that is actually true. So it returns to us something different than we did before by not adding the not. So both of these are, checks. One is checking if it's in there, and one's checking if it is not. So both of these work. Let's see if we do this in a string. Let's say student is equal to, I see, Kent. Oh, we're gonna say E in students. And we run this and we get true, right? Because E is within this string, right? Because fundamentally, strings are just a sequence of characters, a sequence, in other words, a list of characters, right? But in the form of a string. So we are able to use the in operator on strings. We can even say not in students, and we'll see here that we get false because E is actually inside of the name Kent. So therefore, it returns false. And I believe we can do that with integers as well. If we say year 2055, we say 5 not in year. Oh, it does not like that. Okay, disregard what I just said. I'm done. Morty, so it works like a loop. Technically, it does, right? We don't see it. And for those of you that do not know what a loop is, we will cover that eventually. A little out of scope right now. But yes, Morty, what's happening under the hood is that Python is running some kind of for loop, and it iterates through every single item within this list, and it's checking what you're asking of it, right? So it's technically a for loop, correct? All right, logical operators. So using logical operators, we have three operators, which is your and, or, and we just saw the not. So we'll skip that, but we can use the and or the or to chain multiple things together, right? If you're familiar with JavaScript, once again, this might look something like the double ampersand or the double pipes, right? To compare if something is and or, right? So Python is a lot more English friendly. Instead of using ampersands, it uses the word and. Instead of using the double pipes, it uses the word or. So same concept for JavaScript, but in Python, it's actually a little bit more user friendly. So here we have 10 greater than 8 and 23 less than 25. This is still a comparison, guys. We're comparing 10 and 8 and 23 and 25. The only thing that's different here is that we are now using the logical operator and. So it's going to check both of these. So because these are still comparisons, it's going to return to me a Boolean, right? We're just checking two things at the same time. What do you think this is going to return? Correct. It's going to return true. Right. So we have 10 greater than 8, which is true. And then we also want to check 23 less than 25. And if we run this, because both of these pass this check or comparison, it returns true to us. Thank you, Nicholas. A little late, a little late. Right? What happens if I change the 23 to a 27? What do you think this is going to return to me, Nicholas? I see Johnny false, Nicholas false. Correct, right? I can return false to me, right? Because, well, we're telling this to check is for both of these to be compared, right, using the AND method. And if either one of these fails, it's going to return false, right? We're saying, hey, I want you to compare 10 greater than 8 and 27 less than 25. Um, and if either one of these fails, it's going to return false to us. Now let's check the OR operator. If we change this to OR, what do you think this is going to return? Correct, Nicholas. True, right? Instead of saying and, like, hey, I want both of these to be checked, they both have to pass. We want either one of these to actually pass our check, right? Is 10 greater than 8 or 27 less than 25? Even though 27 is not less than 25, we use the or, so it's going to take one or the other. And because 10 is greater than 8, it'll return true. So that is the difference between and the or. Now, let's change this with the membership check. Here on the next cell block, we have 9 in 2, 3, 4, 5, or W and what seems to be some kind of grid coordinate or direction. What do you think this is going to return? True. That's correct. So once again, 9 it's a membership check, right? It returns a Boolean if it's true or false. Although 9 is not within this list, W is within this string. And because we use or, as long as one of these pass, we'll get true, right? So 9 is not inside this list, but W is inside the string. So we get true. Here it gets a little bit complicated. Here we have Boolean 2 is equal to not 4. Oh, let's talk a little bit about this. I think we skipped something like this. I don't know why it doesn't have the explanation in it, but let's talk about the other comparison operators. So we talked about less than, and we talked about greater, and we talked about equal to. Well, what if we want to check if something is not equal to something? Well, instead of using the double equal signs to check if something is not something, we can use the exclamation mark, right? So what this is saying is 23 not equal, right? Not equal to 32. And technically, because they're not equal to each other, when you run this, you get true. So we're able to check if something is equal to itself or if it's not equal using the exclamation mark. We also saw that with the less than or the less than comparison here. What if you want to check not only if it's less than, but what if it's equal to it? Let's say 450. If we say is 450 less than 450, we're going to get false, right? Because technically 450 is not equal to 450. But if we add the equal sign afterwards, it's going to check if it's less than or equal to 450, and it passes that comparison, returning true to us. And same thing can be done using the greater than. Is 450 greater than 450? No, they're actually the same number. So if we add the greater or equal to, it'll return true to us. Do I have any questions on how to compare different data types? Awesome. Let's go ahead and continue moving forward from where we left off. We checked the and, we walked through the or, we even chain using the membership check of in. And now we have not, and then we're checking if 4 is not equal to 5. What do you guys think this is going to return? False. That's correct, right? So 4 does not equal to 5. Well, that is true, but we say not true. So when we run this, it returns false. It's a little confusing if you're new to it. Just know that the not, as you learned before, is checking the opposite. So by using 4 not equal to 5 returns true to us, but then the not counteracts that Boolean, returning false. Now, the comparisons are awesome, right? Using the Boolean expressions, but there is a limit. And that limit is the complete Boolean expression, right? When using the and or the or, you might run into an issue where your comparison is not doing what you want it to do. And that's because when you use the and or, it's looking for complete Boolean expressions. And let's see how that actually works. So here we have, we're printing out some comparisons here. We have 2014 and 2018 in STO Blizzard years. What do you think this is going to return? If you recall, let's look at Blizzard years. Let's bring it down here actually so we can kind of see it in our code. Copy. There we go. We say 2014 and 2018 and STO Blizzard years. At first glance, we're thinking, hey, we're checking if both of these are inside of Blizzard years. And if we look through it, we see 2014 is not, but 2018 is, right? So at first glance, you would think this would return false because we have the and, right? We're checking for both of these to be in Blizzard years. But when we run it, we get true. And why is that? Well, because technically, this is not a complete Boolean expression on both sides of the and, right? Expression, right? So when we run this, it checks 2014, but what it does here, it's checking if it's truthy. Now, what is truthy? Well, something that is truthy is a value that is not zero, false, none, or an empty string or an empty collection like a list, right? Because we didn't add a complete Boolean expression where we check this 2014 and STL Blizzard years. By default, it's just going to check what the value of 2014 is, right? It's not a complete Boolean expression, so it reads 2014. It doesn't see anything afterwards before the and, so it doesn't know what to check, whether it's in something, whether it's less than or greater than, or whether it's equal to something or not equal. So it's just going to grab that integer and it's going to say, okay, well, because you don't have a complete Boolean expression, I'm just going to check the number. I'm going to check if it's truthy. Is it not zero? Is it false? None? Or is it an empty string or an empty collection like a list? And because it's neither of those, it'll pass. It'll be true. And it'll move on to here. And it checks its 2018 and STL Blizzard years, which technically it is not. So it'll, I'm sorry, correction. Let me take that back. Technically it is. So this returns true as well. And because both of these return true, it returns true to us. Now let's say if we do 2017. Notice that we get false. 2014 is a truthy number, right? It is not zero. It is not false. It is not of a none type, and it's not an empty string. So this actually returns true to us, but because we're using the AND operator, when we get here, 2017 is not in Blizzard years, so it fails the check because of the AND, therefore returning false to us. I can understand that this might be a little confusing, so do I have any questions on the complete Boolean expression? Hey, Roger, how do we make sure that we check that 2014 is also in STL Blizzard years? Well, you have to complete the Boolean expression on the left side of this AND by saying 2014 in STL Blizzard years and 2018 in STL Blizzard years. And notice that we get false, right? Because now this is no longer just checking the individual number if it's truthy. Now it's actually a complete Boolean expression. So therefore, it's going to check if it's actually within this list, as well as 2018. 2018 passes, but because 2014 failed, the whole thing failed and it returns false to us. Do I have any questions about incomplete Boolean expressions before I continue forward? All right. I'm going to take your silence as a good response. So we'll move forward. Here we see the correct logical operator statement. All right. If statements, right? If statements. You see me use it a little bit. Some of you guys might not know what it was doing, right? What the if statement allows us to do is check a certain line if it meets a certain condition, right? We saw a little bit before already of that on my code, and we kind of got a hint of it working with the Boolean values. And we see the explanation here. We have a variable called temperature with a data type of integer of 70. And then we use the if to check if the temperature is less than or greater than 32, right? So we say if temperature is less than 32, I want to go ahead and do the following. And now we see some nested code in here. we're starting to see the indentation. Once we get to line 2, where we check if the temperature is less than 32, if this passes, then we need to do something, right? And the way that that works is by using a colon, letting it know, hey, after this check here, if it passes, I want you to do everything that's after the colon here. And then the way that you start that line of code is by going into the next line and using the tab, right? You either press the tab once or you add the 4 spaces within here, starting a new code block, right? So it gets to line 2, it's gonna check, hey, is temperature less than 32? Well, if it is, I want you to go into this code block and do the following, which is print there could be a chance of snow as a string. But in the event that the temperature does not pass this check, it's going to go into what we call an else statement, right? So if I do not pass this check, do what's in the else block. And when it does not pass it, it gets to the else and it says, all right, we did not pass the previous check, so I'm going to do the following within the else block. We start it with a colon, and then we start a code block where we have the print statement, there is probably not going to be snow. Now, temperature is not less than 32, so when we run this, it gets to line 2, it sees, hey, temperature is 70, it is not less than 32, so I'm going to go ahead and skip this next line because I did not pass this conditional statement. And I'm going to go to the else block and run the code. There's probably not going to be snow. Now, if we change the 70 to 20 and we run this, the second time it runs, it's going to get to this line of code and check if it's less than 32. And this time it did successfully pass this check. Therefore, we ran what was inside of here. Notice that's all we did. We never reached the else block. We didn't have to get here because we passed the if statement. Do I have any questions on using an if or an else statement? Joshua, the indentations need to be aligned, right? Technically, yes, right? It's looking for 4 spaces, right? That's what starts a new line of code. If I take off 1 space, right? I did 3 spaces instead of 4. And I run this. What the heck? Why are you doing what you should be doing? Let's do this. There we go. Okay, so we see here, because they don't match, right? We have one format here where we're using 3 spaces, and then this one we're using 4. It's taking this as the first line of code and the standard. So when it gets to the second one, because they're not properly indented or aligned, we get an unexpected indent. Right, so yes, they do have to match. Does that answer your question, Joshua? Awesome. Let me clear the output. Now, this is cool and all. We're able to check if something is less than 32, and if not, let's do something else, right? But what if we want to add multiple options to check besides just this one option, right? Well, here comes the following. And the way that we do that is by using an elif statement, which is short for else if, right? And it allows your lines of code to check multiple different options. Let's talk through this code. We have the temperature once again, which is 70. And we say if temperature is less than 32, then I want to do the following. And let's, I'm sorry, I actually edited this. I'm gonna ignore this one real quick. Let's talk about this one first because this one's a little bit more nested. So ignore this one. Let's talk about this one. All right, these are backwards. I should have formatted these. My apologies. Um, let's look at this one first. This is using the else if block. Here we say if temperature is less than 55, I want to print layer up and stay warm. And then we have an else statement where we say else if the temperature is less than 32, do the following. So what's happening here, if the temperature is not less than 55, I want to go to the next one, right? If it doesn't pass this one, I want to go into the else statements, right? Because that's all that follows. Notice that technically temperature is below 55 and it is below 32. So what happens when we run this? We get layer up and stay warm, right? Why does it do that? Well, because it's going to read it one at a time. It gets to the first one. If temperature is less than 55, I want to do the following. If this passes, the rest of these do not pass, right? It never even gets to the second statement, which technically negative 60 is less than 32, but this isn't exactly how we want it, right? We wanted to ensure that if it's, sure, they might be less than 55, but if it's also less than 32, we want this one instead of the layer up and stay warm. And that's, a conflict for us, right? And we're going to talk about how we can fix that. But here, if less than 55, then do the following. Negative 60 is less than 55, so we run this and we never even get to the next statement, right? It stops everything else and it skips it and just prints out layer up and stay warm. So how can I fix this to check if it is also less than 32? Sure, we can switch 55 and 32. That is one way. If we just add 32 here and add 52 here, then instead, when it gets to the first time, it's going to check if it's less than 32, and it will say layer up and stay warm, right? But we would have to switch these up as well. There we go. Let's run it again. All right, here we go. Now it's actually doing what we wanted to do. We're saying if temperature is less than 32, then I'm going to print out it is literally freezing outside, stay inside with jammies in hot cocoa. If it's not less than 32, then I want to move forward because it means it's probably higher than that and just stay layer up and stay warm. If it's not less than 52, that means it's even hotter. And we want to say looks to be a nice day. That's one way of doing it. Another way is by adding an or statement, right? So if temperature is less than 55, oh, correction, not an or statement. Let's say and. We're going to use an and statement. If it's less than 55 and greater than 32, and temperature is greater than 32, then I want to say layer up and stay warm. If it's not less than 55 and greater than 32, this is going to fail. And it should move on to the next line of code. And if we run this, we see here that it failed the first check because it's not greater than 32. It's negative 60. So it had to pass both of these checks here. Although it passed less than 55, it did not pass the second one after the and statement. So it went ahead and moved over to the next line of code, which is checking if it's less than 32, which is true. Therefore, it runs this line of code. So two ways of doing it. You can either, yes, reformat it so you have it in order, which is the smart way of doing it, or you can also do this way. So either way, it will do the exact same thing. Do I have any questions on using the if else statement or the else if? All right. Well, now let's look at this one, which is a little bit more nested. We have the temperature, which is 70, right? It's no longer negative 60. It is 70. And we're going to say if temperature is less than 32, we want to do the following. Notice that once it gets it here, we have another if statement, right? Sure, it might be less than 32, but what if it's even lower, right? What if it's lower than 10 as well? Once it passes its check, it's going to get into the next check where it's going to check if it's even lower than 10. And if it is, it's going to print out it's dangerously cold outside. But let's say it wasn't less than 10. Let's say it was 25. It passes the first check, but it won't pass the second check. So therefore, it never runs this line of code where it's printing out it's dangerously cold outside. It's going to skip this, right? Because it did not pass its check. But it will definitely print out it is literally freezing outside, stay inside the jammies in hot cocoa, right? It's not so cold where it's going to print out it's dangerously cold outside, but it's cold enough where you should still probably stay inside and stay warm, right? If it doesn't pass the 32, it's going to go to the next elif statement, which is going to see if it's less than 55. And if so, prints out layer up and stay warm. If not, that means it's not cold, right? It's not less than 55 or further. So it should print out, looks to be a nice state. And we get that it looks to be a nice state. Now let's edit the temperature. Let's make it 25 so we can actually pass this check here. So now it is 25. It's less than 32, so it should pass the first one, but it's not going to pass the second one, right? We run this. It passes the first one, so it's able to go inside this code block. But then it reaches another statement where it's checking if it's less than 10, and it fails this one, so it moves on to the next part of the code block, which is printing out it is literally freezing outside. Let's go ahead and change this to 5. When we run this, it runs both, right? It passes line 32. So it goes in here, it checks if it's less than 10, which is also true. So it does print out it's dangerously cold outside. But notice that the next line still runs, right? Regardless, even though it passed this one, it does not stop. We print out the next statement because this is not within an else block. And now if we add else, we get it's dangerously cold outside. There's no reason to print out this one because it's not between 10 and 32. All right, so this is another way of doing it. Do you have any questions before we move on into our first break of the night? Can you use elif multiple times within the code block? Yes, you can, absolutely. Let's say elif temperature less than 65. It's a little chilly outside, right? So here we have two elifs. Let's make this 60. And if we run this, it fails the if statement for less than 32, so it never runs this line of code. It fails the less than 55, so it doesn't run this, but it passes the less than 65, so it runs this line of code, right? It never runs the else statement because it actually passed one of these elif statements, and it prints out it's a little chilly outside. So yes, you can chain multiple elif statement, Brandon, right? That is the sole purpose of the elif statement. It allows you to add more than just one conditional statement. Does that answer your question, Brandon? Awesome. And there's no limit to it. You can keep adding in here to check multiple conditions. But yeah. All right, time is 7:05. Let's go ahead and take a 10-minute break and return at 7:15. All right, welcome back, everybody. We're gonna go ahead and continue with the class. Uh, Before I actually move forward with the class, do you guys have any questions? I feel like you guys have been very quiet. I want to make sure everyone's understanding everything that's been covered so far. Um, any questions whatsoever about anything in the lesson? I am here. Tristan is also here. Usually you would be doing this by yourself. In an empty room, breaking your head trying to understand a concept. So, I highly encourage, ask as many questions as you guys can. Uh, we're here to answer anything that you guys might be confused about. I would hate for you guys to leave the lesson today and feel like I have no idea what, Roger was trying to explain to us. Okay, I see Marianne, good, Rashawn. I highly encourage it. One thing that, I kind of told myself when I was going through the program is I was going to leave my ego at the door. And what I mean by that is that, when we first start coding, it can be a little intimidating, especially when you're in a class setting. No one ever wants to be the one like ask questions. But the way that I saw it is that I was transitioning out of the military and I was putting all my money on this to work out, right? The way that I brought food to the table for my family was going to depend on what I got out of this program, and that was important to me. That helped me uh, ignore the fact that maybe I was asking a little too many questions, right? Because you have those people like, oh my, this guy doesn't shut up, right? He's just asking so much. I want to continue the class, but I did not care, right? So I would ask my questions. I would talk to the instructor on the side. They would help me whenever I was confused. And that was kind of the mindset that I went into this program to ensure that I got as much as I could out of the resources that were being provided for me. And I highly encourage that every single one of you guys in this class takes up that mindset and ensure that you do not leave today or any of these days confused about what happened. Uh, I see Marcus, the main part that concerns me is that I learn best by actually doing it. So I feel like I get it now and forget parts of it. Yeah, absolutely. That is definitely something that happens. It is, perishable skills. So you kind of have to do it. And it's not something you can just watch a video or watch someone do if you're not doing it yourself, right? That was the main point of kind of giving you guys a curriculum and some kind of area where you can do some code, where you can make those mistakes. So um, that's why Jupyter Notebook is good. Uh, so you're not just running the program that's already here for you. I recommend as it's being taught to you, kind of code along to what's being here. Get some practice in as you're going through it if you can, uh, and see how it works because that's the only way of learning. We'll have enough time today to kind of go over some examples and maybe even look at the exercises today. We are doing great with time. So we'll take, 10, 15-minute breaks to try out some exercises and see how that works. All right. So we talked about the code block and how this was before. Let me go ahead. There we go. We talked about how to fix this, right? And the way that this works, it's going to take this very literal, right? Coding, and I was talking to one of the classmates before about programming. If you guys have ever seen the video of this father who gave his kids a task of creating a step-by-step instruction of how to create a peanut butter and jelly sandwich, you'll realize that programming and coding is very similar to that, right? In this video, and I highly recommend you guys look it up. He told his student or his kids, hey, write down the instructions of how to create a peanut butter and jelly sandwich. And they did. They say, grab a piece of bread, put jelly on the bread, put peanut butter on the bread, put both sides together. And then he didn't do it wrong, but he took their instructions very, very literal, right? So he gets the slice of bread and he reads the instructions and says, put the jelly on the bread. So he gets the entire jar of jelly and puts it on the slice of bread. right? And the student and then the kids get very frustrated, like, no, like you're doing it wrong. Well, they're, that's how you told me to do it. So they go back and they, rewrite their instructions, and the kid says, grab a spoon, put the jelly on the spoon, and so on and so forth. And he does it very literal. He grabs a spoon and puts the jelly on the spoon. And they get even more frustrated. And what that video shows to you guys, it's a great representation of what your code does. It's gonna do exactly what you tell it to do. So you have to be very specific on the instructions that you give your code. And when you start off, it's okay if you are a little bit deliberate, very deliberate, if anything, on everything that you do in your code. You don't have to be great at it. It doesn't have to be the most clean code. The important thing is understanding what you are doing, how you're doing it, and getting that task, accomplished. As you guys get better at coding, you'll find much more efficient ways of doing it, which might look a little bit more cleaner and might run a little bit faster. But your code is only going to do what you tell it to do. And that's what's happening here. We have, if temperature is less than 55, I want to print out, layer up, and stay warm. Temperature is less than 55, but you're not specifying it to also check if it's less than 32. It's running this line of code, and it's going to do exactly what you tell it to do. This does pass. Negative 60 is less than 55, so I'm going to go ahead and print, layer up, and stay warm. All right, that's exactly what we told it to do, but we didn't let it know that it has to be, greater than 32, right? So it did not know to move forward with the line of code and check whether the temperature is less than 32. So very similar to that video of the father teaching his kids how to write instructions for peanut butter and jelly. That's how your code is working. So you have to be very deliberate on what you want it to do. And I'll share that video at the end of class so you guys can look at it, or you can just kind of find it on YouTube. It's very amusing, but it's a perfect example of what your code does. But all right, enough of that. Let's go ahead and move forward with the class. The next thing that we're going to talk about is going to be Python functions. Now, normally, functions is a much more advanced topic. You would want to learn stuff like for loops and while loops and all that stuff before we talk about Python functions. But it's purposely done early on the class because we understand that there's many people of different levels. And technically, you do not have to complete the course before you're ready to take the assessment. You guys should have all received an email yesterday specifying that, right? If at any point in the course you feel like you are ready to take the assessment, you do not have to continue, and you can go ahead and do the assessment if you feel ready. And because of that, we do this part first, where we teach you guys functions because it is part of the assessment, I believe, right? So it's important to know in case you are already at that point to move forward with your application. So Python functions, right? We saw functions already a little bit in yesterday's lecture, and those were the built-in methods. And methods is honestly just another fancy word for a function, right? It's doing something. We don't see the code that defines this function. It comes pre-installed with your Python download whenever you install Python onto your computer. Here we add it as an extension, right? It comes with Python. But Python, and like every other language, gives us the flexibility to create our own custom-made functions, and that's the beauty of these programming languages. To be able to isolate our code to an individual code block or block of code to do a certain task, right? And it allows us to reuse that piece of code somewhere else. And we'll see how that works. Let's see. For the function, there's a certain way of doing it. Here's the first example. We'll use the example from yesterday. One of the methods that we saw was capitalize. Now, I will say, if you guys are using the same curriculum from yesterday, you might notice that the curriculum might be a little bit different than what I'm showing now. That's because I edited it today. So just be aware of that. If you want to reset up your code space for later, I did change it because the example that was being shown here was a little bit too advanced for people that might have already or just started coding. So I added the example to show you a much more simpler version of doing this. Now, in this example, we have a variable called my name, and it's holding my name in all lowercase, right? And then we are leveraging the capitalize method that comes with Python to capitalize the first letter of our string. Now, we don't see how this works. We just know that we are using it, and we know how it achieves, or we know that it can achieve A to B, but we don't know how it reaches from A to B. So we add my name dot capitalize, and then we print out capitalized name, and we see here that it was able to take in that string and returns to me with the first letter of the string capitalized. Now, how does it do that? Well, we're going to talk about how functions work. We'll even recreate this method our own self to show you what's probably happening underneath the hood. Now, what do functions take, right? Functions can take inputs, which what we call parameters, right? This allows us to pass data into the function for processing. I'm sorry, give me a second. My wife is here and I locked her out. I'll be right back. Give me 30 seconds.
Hey, Roger, I think you're muted.
Thank you. Yeah, I do apologize for that issue. Right, getting back to the code. So the parameters, right? This can be whatever you desire, similar to
Roger,
yes.
remember to record, please.
I am recording. Thank you, Sarah. I appreciate it. Yeah, going back. Thank you for that, Sarah. It happens a lot, guys. So if it does,
No
you know, if
problem.
I don't record, just let me know. But yeah, so these parameters, very similar to variable names, they can be whatever you want to call them, right? Ideally, you want to make it so it's something that's relatable to what your function should be doing, right? For example, my variable here is called my name, right? And it holds my name. That allows me as a developer to know what is actually assigned into this variable. Now, the parameter should be given a name that lets you know what type of data should be passed in. So how to define a function? To define a function, we use the statement def for def, right? Which is also short for define. After declaring the def statement, you're going to give it the name of your function, similar to your variable. Right here, I have an example function called total sum. And you can kind of already, have an idea of what this function is going to be doing. It's going to give you the total sum of something, right? After you use the def statement and you give it its name, you use the open and close parentheses. What these parentheses are for is so you can define what parameters it should be taking, right? It takes two parameters. Notice that I gave them the name of num1 and num2, right? The naming convention is important, so I know what I'm actually using this function for, right? We define what our parameters should be, right? Within these parentheses. After that, we use a colon to let our interpreter know, hey, everything following this is going to be a part of the function. Is everyone still with me? All right. Let me know if you guys have any questions, because for me, as a beginner coder, when I first started, functions confuse the heck out of me, right? So that's how we define our function. Now, the actual inner workings of the function is what is the conditional logic that we are going to use to receive a result, right? What we want our function to do. That comes after that colon. So after that colon, you go to the next line, and then you start an indentation, letting it know, hey, this is a new code block that belongs within this function, right? That is important. right? The moment you unindent, what Python is interpreting that as is, hey, I am no longer within my function. I'm now outside in the global scope of your program, right? So we have to indent to go inside of this function to give it some kind of logic. Within this function, I see here that I create a variable called sum. And I do apologize. This is a typo. This should be num1 plus num2. There we go. How to edit markdowns, guys. If you hover over the markdown, you should get this pop-up. You click on the pencil, and it lets you to, allows you to edit the cell, right? And then I added the num plus 2. Right, so this function has the logic of creating a variable called sum. And what sum is doing, it is taking the parameters num1 and num2 and adding them together, right? I want you guys to think about you defining your function as creating the instructions of how something should work, or like a recipe, right? When you look at the recipe, the start of it tells you the name of the recipe, right? That's the name of our function. And then there's an ingredient section, right? Those ingredients in our code are our parameters. And then within this recipe, you have the instructions of how to utilize those ingredients for your dish, right? And that's what we're doing here. These are the instructions of how to use the ingredients or our parameters to accomplish the outcome that we are trying to create, right? So we have this variable sum is equal to num1 plus num2. Now, to properly call the function, you have to call the name of the function and then pass in some values inside these parentheses so they can take the place of what those parameters should be, right? So here we have an actual code block. I am defining my function total sum. It has 2 parameters that I am naming them num1 and num2. And then inside this function, I have the logic where sum is equal to num1 plus num2, and then I want to print out sum. After that, I'm calling my function twice. On the first line, I'm actually passing in 2 arguments, or we call these arguments. So arguments and parameters. Roger, why you call them parameters earlier, but now you're calling them arguments, right? We call them parameters whenever we are defining the function. When the function is already created and we're actually calling the function and using it, they now become arguments, right? This is what we're passing into the parameter, right? So the arguments for this function are integers 2 and 3. On the next line, I'm calling my function again, but this time I'm only passing in 1 argument, right? And both of these are going to give me 2 different outcomes. When I run this, the first function runs and it returns 5 to me, right? It was able to take in both these integers. It used those to add them up together and save them in sum, and then I printed out sum. So when this line runs, it runs this function using the arguments that I passed in, and it works successfully. Now, the second time I do this, I get an error, right? Who can take a guess of why I got this error? Yeah, only 1 argument. The recipe called for milk and eggs to make this cake, but I only passed in milk and no eggs, right? I don't know if that's correct. I don't make cakes, but that's exactly what's happening here, right? The recipe asks for something, right? The function, the instructions say that it requires ingredients, so it's not going to work, right? And that's what's happening here, right? Imagine trying to bake bread, but there's like no yeast, right? It's not going to give you bread. I don't know what it'll give you, but it ain't bread. All right, that's what's happening here. It has the 2, and that's going to take the place of num1, but there's nothing for num2. So when it tries to run this function and add num1 and num2, it doesn't know what to do. So it returns an error, and it says total sum is missing 1 required positional argument, right? I see more to your comment. We'll get to that in a bit. Absolutely, right? So this didn't work. That's because the way that I created this this function requires me to add num2. Right? Now, I see here that Morty said set a default parameter. That is absolutely correct. You are able to give the default in the event you want to run this function and not always give it another argument, right? So the way that I would do that here, within the definition of my function, I would say num2 is equal to, let's just give it 1. Right? So by default, num2 will always equal 1. Now let's see how that works when I run this. It runs the first time, and I passed in 2 arguments, even though there is a default on my definition. But because I passed in that second argument, it overrides the default, right? And it runs 2 and 5 and returns to me, 2 and 3, and it returns to me 5. The second time I use this, I no longer get a type error. I actually get the response of 3, right? What it did was it used the default of 1 to fill it in that gap of what I lacked to give it. And it still was able to complete its functionality and return 3 for 2 plus 1 being 3, right? So you are able to give it a default. Correct, Morty. Do I have any questions on how we define a function and how it works? Now, what happens if I remove this line of code where I say print sum? If I run this, it doesn't return anything, right? So let's see if I print out the actual function itself. I'm going to wrap the function call with a print statement. And when I run this, I get none, right? Very similar to a variable, right? And let's write it out so I can explain it. My variable is equal to 0, right? What happens when I print out this variable? When I run this, the print statement is going to grab the variable called my variable, and it's going to grab the information that's stored within it and return it inside of this parentheses and print it out for me, right? Because it actually has information to return to me. By default, when I run the print statement on the variable, it'll print out the return of that data type. For functions, it's a little bit different, right? The function is not returning anything at all. So when I try to print the function itself, it says none because there's nothing being returned to me. And that's when the return statement comes into play. Here, it's essentially the same line of code that we had above, but instead of doing print sum, I said return sum. So let's remove this and say print. If I wrap a print statement around my function, and let's also do it here. Now that I wrap the print statement around my function, and my function has the line of return sum, when it goes to print this out, it runs the function, it takes 2 and 3, adds them together, and when the function is done running, it's going to return the sum inside of these 2 parentheses, and it's able to print out that sum for me, right? It's no longer giving me none, because now I am actually returning something to it, right? Once again, none is the absence of data, right? Because I wasn't returning anything, there was no data for there to return, therefore it returned none. I'm also able to run this function because it's returning none. I'm sorry, not returning none, because it's returning the sum. The sum is being saved into this variable called sum, and I can print that variable out, and I get 5 as well. Does anybody have any questions on how a function returns data? All right. Silence is compliance. So I'm gonna go ahead and move forward. So if the return statement isn't used and you attempt to save the answer from your function, you will come to find that the value will hold none. We saw that at work here. We tried to run the function and save it into the variable called sum, but when we try to print sum, it returns none because nothing was being returned from the function. Now, we talked about the capitalized method that comes with Python earlier. Now let's look at it on a custom-made function, right? This is, I don't know if this is exactly how it's working, but this is pretty close to how that built-in method works and what's running under the hood. The only difference is I created my own method or function to do the exact same thing. So here I define a new function called capitalized name, and it's going to take a parameter called target name. Right? This is just a naming convention I'm giving it. Within here, in my instructions, I am creating a new variable called capitalized letter, and I'm going to assign it what? What is this line of code assigning? I'm gonna start calling people. Abigail, what is this line of code doing and assigning into my capitalized letter? All right, I'm assuming Abigail is busy. Morty and Rashawn, you guys are absolutely correct, right? What this is doing, it is grabbing whatever is being assigned into target name, and I'm going to grab the item or a character or whatever it may be at index 0 of target name. Right, so this is returning me whatever is at index 0 of target name. After that, I run the dot upper method on it, and it capitalizes that one letter and assigns it into my capitalized letter variable. I then create a new variable called formatted name. And what I'm doing here, who can guess what's happening here? This is building off of what was taught yesterday. What's happening here? Yeah, it's concatenating the two variables, right? It's concatenating the rest, attaching the capitalized letter to the rest of the name. Absolutely, all three of you guys are correct, right? It's taking that letter, right? Essentially, if target name is, let's say, Roger Lagarza, what happens here is that it grabs the R and it converts it to a capital R. And then line 3 is going to grab that R and it's going to add to whatever returns from this. What is this called? What is the term of what is this is doing? It is using start stop. It is, but that's not the actual term, right? The one is the start, and what's after the first colon, it is the stop. But this method or whatever I'm doing here is called slicing. There you go, Morty. Correct. We are slicing that string. We're going to grab the items in that string that start at index 1 and then the stop, because we added nothing by default, it's going to grab everything else to the right. So this returns to me OGER space DELAGRZ, right? This part of the string. So we have two strings here, capital R, and we're adding the sliced version of my original string, which is the rest of my first name, the space, and the last name, and it's going to concatenate them together. And then now that I have that formatted string, we return formatted name, right? Now, let's see that at work here. We're calling the method 3 times. both of these functions, they have three different strings. We have my name, we have Joe Smith, and we have Adam Hood. And then whatever is being returned from this function, we're gonna go ahead and print out the result. So I run this, and we now see that we successfully capitalize the string. And this will be the same as saying, let's go ahead and create my name is equal to, I'll give it my name. And then let's print out capitalize, right? Both of these are doing the exact same thing, right? This is going to print out the capitalized version of my name. And then we're also printing out using my custom method, right? So we were able to recreate that built-in method that came installed with Python, right? Hopefully that kind of gives an example of how these built-in methods work. If you don't see what they're doing, just know that whenever you install Python, right, all this code is coming with it, so you can leverage these functions already, right? It allows you to essentially do so without having to what we call hard coding, right? This we would consider hard coding, right? I'm hard coding the functionality of capitalize, which is not needed, right? If I've already have a built-in method for it, why would I want to recreate the wheel, right? That is the power of functions. Do you have any questions about the capitalized name function that we recreated here? All right, let's talk about custom find method, right? This is one of the methods that we saw yesterday as well. And this is just another example of how we can kind of recreate how that works, right? How does the find method work? What does it return to us? Does anybody remember? When we use the find method, what did it return? And the answer is kind of already here. So I'll just go ahead and say it returned the index, right? But let's say we don't want the index. We just want to see if whatever the item that we're trying to find actually exists in there. So we want something like true or false. We don't want some number. Just tell me yes or no, right? So we're almost kind of like creating a new version of the find method, but specifically to just work for the name. So here we define the function called find name, and it takes two parameters, target name and the input data, right? We create present equals true. Let's do some formatting here. Yeah, present equals false. All right. And then let's return present. The reason I'm doing this is so we can see it, the other stuff that we've been learning to use in action. So here, here's how we can use like present or a Boolean as a way to get a yes or no response, right? So here we create a default of what present should be, which is false. And this variable is essentially keeping track if the name that we're trying to find actually exists within the input data that we're given. It helps us keep track of a yes or no response, right? And that's the power of Booleans. Here, we next create a new variable called name location. And what this is going to do is going to take whatever input data is, and we're invoking the .find method. And if you recall from yesterday, the .find method takes in some form of input, and that's what it utilizes to look through whether the list or I believe you can use it on a list or the string, and then it returns to you an index, right? Returns an index if exists. Else returns -1. So that's something that the find method does. In the event it doesn't find the item you're looking for, by default, it'll return to you -1, right? Pretty much saying, hey, the actual index itself does not exist. So here's -1 to let you know that. Right? That's how that find method works. So after we run the find method into the input data, we're going to check if it returned to us the index where it's located at, or if it returned -1 to us. So we use an if statement to check if the name location is equal to or not equal to -1. If it's not equal to -1, that means it probably returned to us a positive index, letting us know that it does exist in there, right? If it does return a positive index, that means it's present, so present should equal to true. But if it does return a -1, that means that it did not find a name, so present will equal to false, right? Once we run this logic, all we do is just return whatever present is, and then we can use this function to actually see it work out. Here is a variable called long string of data, and it's just a long string of different names. And now we can utilize that function we created. What arguments does it take? Well, it takes a target name. Well, that target name is going to be the name I'm looking for. And then the second parameter that we defined was the actual data that we're trying to search through. So that was our long string of data. It uses these arguments to actually run through the logic within my function, and it should return to me either true or false. And when I run this, all of these actually exist, so I get true in all of them. Roger de Lagarde is here, Bill Smith is here, and then Frank Scott is here. Well, what if we have Frank Scott exclamation mark? Well, it returns false because this specific string itself does not exist. Frank Scott with no exclamation mark exists, but that's not what we're looking for. We're looking for Frank Scott exclamation mark. Therefore, it returned to us a -1, right? So present was equal to false, so we get false as a return. Do I have any questions on the custom find method? All right. If you have no further questions, we're going to go ahead and move forward. I believe, all right, we're close to the end. So the next thing to talk about is going to be the function scope, right? Like I mentioned before, you can think of a function as a mini program, right? It does something with whatever you give it, and it gives you some form of result. But there's something to take into consideration when working with functions. And now this might seem a little overwhelming, and we'll talk through it. But there is such thing as local and global scope, is what we call it. The global scope is what we would define as the overall top level of our program, right? The top level of it all. Everything that's not within some form of function, right? Everything between defined number processor up to the end of where the code block ends, that is what we call local scope. What that's saying is everything that happens within this function stays in this function unless we are returning it, right? So the only thing that ends up coming out of this is within the return statement. If we were to declare something inside this function and we try to use that outside the function, we're going to get an error, right? Because that variable only existed when this function was running, right? The local scope of the function itself. It wasn't in the global scope of it all. So if something is declared inside the function, we cannot access it from outside unless it's coming back from the return statement. Vice versa, though, the same thing cannot be said about the other way around. The function itself is able to access other items from the global scope, right? So if you're in the function, you can access things from the rest of the program that isn't within another function, but the global scope cannot access stuff that's happening within this function. Now, let's see that work. We declare a couple of variables here. There's no true meaning to this. It's meant to show you how things change as it's being ran. But we declare some stuff within the global scope, right? This is not within some kind of code block, like a function. It's within the global scope of my script. We have my number, my other number, and my operation, right? Both of these are just normal numbers. And then the my operation is letting me know whether I'm subtracting or adding, multiplying or dividing, right? It's a string. But I'm going to utilize this in my function. I also have a random number called 1,000. And then within my global scope, I'm printing out random number before function runs. This is an interpolated string. And this string is utilizing the random number variable to concatenate it and give me some form of formatted string. All right, so normally this will all run globally. All right, so when I run this, this should run. And then I get to the function part of my code, where I'm defining a function called number processor. I am leveraging the number 1 and number 2 in operation, right? So these parameters, it looks like 2 of these are numbers, and the third parameter is some form of operation. And we can see that when I'm actually using the function here, what do we pass in? We passed in the my number, my other number, and then my operation, which was a string of a minus. That's what's being used as arguments. And here within the function itself, we're running some print statements. We're printing out inside the function, and this is going to allow us to see when the function itself is running. So whenever we call the number processor, all this will be ran. Notice that the random number is being assigned the integer of 700, where originally outside of this function within the global scope, it was 1,000. But in the function itself, I reassigned it a new integer. I then continue to add some other print statements, right? I am printing out random number inside the function, and I'm adding the random number in here. Do you think this is going to print out 1,000 or 700? Correct, Nicholas. It's going to print out 700 because within my function, I am reassigning the 700 to it. So when it gets to this part, it's going to check the random number, which is 700. It's not even going to worry about over here because within this function, by the time it gets here, what matters is what's happening in here, and it's being reassigned. So this will print out random number inside the function, and it's going to say 700. We then print out another interpolated string, and it's the result of, notice that we get num1, the operation, and num2. So this will essentially say 5 minus 6 is, and then we have num1 is equal to 9. All right, so we're just essentially just doing some print statements to see how these variables work within the function. We then go ahead and come down here, and we're doing some if or else statements to see if it's either a plus, a minus, division, or multiplication. And depending what it is, we do either or. And then we print out returning to let us know when the function ended, and then we end the function. Well, let's see that at play here. We run this. This first line here, random number before function runs, is being called within the global scope. All right, at the first part of my program, I'm printing out what random number is, which was 1,000 initially. It comes down here, nothing runs because all this is doing is defining it. We're not running anything here. We're just defining what the function is, right? We're creating that recipe, right? Those instructions for what the function should be. So nothing happens here. But when we come down here, this is where we actually run the function, right? We pass in the number, which was 5. We pass in my other number, which is 6. And we pass in the my operation, which was a minus. This function runs. It prints inside the function. Notice that the next line that got printed out was inside the function. We then get to this part right here where we reassign the number and we print that out. And we see here a random number inside the function 700. So you guys were correct. The random number became 700 and it printed it out. We then printed out the result of num1, which is 5, operation, which is a minus, and num2, which is 6, is, so that's working. I can see that num1 and num2 are still the same. I get to this part right here. I'm doing some logic here to see if I divide or not. And then I return the result, right? Notice that I changed num1 to 9. So when I actually do the logic here, instead of returning 5 minus 6 is equal to -1, that 5 became a 9. So when it got to this part, it subtracted 9 minus 6 and returned 3. Cool. So we see that the num1 changed. All right, well, let's continue. I then print out my number again, right? And notice that my number is actually 5. But wait a minute, Roger. Inside your function, you reassigned it to 9. That's correct. But that was within the local scope, right? Within the global scope, it did not change, right? The number, my number, which is 5, stayed the same. So when I print it out after my function runs, it still prints out 5, even though within my function, I said it was 9. 6 never changed. And then once again, at the very end, we see random number after function has run, and we print out the random number again, which was originally 1,000. In my function, I said it was 700. But at the very end, after everything was said and done, the random number is still 1,000. That's because the reassignment was within the local scope of that function. It did not affect what was in the global scope of it. Does anybody have any questions about what I just covered?
Question.
Answer.
I probably like zoned out a little bit. Like, how come that my number, num1 captures the value of my number? Like the
Right.
num1 captures the data of my number, like inside the function.
Yeah, because that's how we define the function to work, right? We gave it the parameters it's supposed to take, num1, num2, and operation. When we actually run the function, we pass in the variables that should take place of those parameters, right? Num1 ends up taking the my number variable. Num2,
Oh, so you mean to say it's like reassigning?
yeah, pretty much.
Okay,
right.
I see.
In a sense, this is kind of creating a blueprint to let it know what argument it should be taking. So when it runs, my number gets used as if it was num1. Make sense?
Yep, thank you.
In short, guys, global scope. Let's go ahead and add some comments here. Global scope cannot access local scope data, but local scope can access global, right? So the global scope, right? The root of my program, it cannot access anything that happened within here, only whatever is being returned from the results. Right? So even though I reassign whatever my number was inside my function, my global scope has no knowledge of that. But local scope is able to access items that were declared outside of my function, right? For example, here, I'm printing out the random number, which is within the local scope, but I never passed it within my arguments, right? It wasn't passed as one of the arguments within my function. And that's because it could still access the global scope variables, right? So in short, global scope cannot access local scope data, but local scope can access global scope. Do I have any questions before I move forward? All right. Well, time is 8:07. We're gonna go ahead and take our last 10-minute break of the night. I want to reiterate for anybody that might have came in late today. I'm gonna go ahead and drop it in the chat. I do have an attendance form. If you guys can fill it out, please. It takes like 15 seconds. It's in the chat. Fill it out during your break, and I will see you guys at 8:17. Welcome back, everybody. We're gonna go ahead and continue with our last 43 minutes of class. We are close to the end, and we'll take a little bit of time to kind of go over some of these exercises that we have. So we talked about global and local scope. Now let's say a little bit more simpler, right? So here we have a function called my function. Inside this function, right, the actual functionality of it, we are declaring a variable called x and assigning it the integer of 10. And then we're saying, hey, print the inside function and then followed by x, right? So we then call it, but notice that afterwards we're trying to print the variable x that was declared within my function, but it's almost like squiggled out. It's telling me that there's probably going to be an error here because it doesn't recognize that. That's what usually the squiggle line is telling you. And it says x is not defined. And even when I run it, I still get the error. It says name x is not defined, right? Why is that? Well, once again, because it happened within the local scope of this function, it doesn't have access to it in the global scope of it, right? So it can't do that. Whereas if I did y is equal to 20, and within my function, I say print y, and I run this, notice that when my function ran, it runs the first line, which is print y, it printed y, and declared a variable called x. It says printed inside function, and then the 10, which was the x. But when it got to this line right here, where we try to print x, x still didn't run, but for some reason, my function was able to run the variable y. And that's a much simpler version of what happened earlier with global scope and local scope. So the function can access global variables, global data, right? But the global scope cannot access the stuff within the local scope of a function. Right, this is a much simpler version of seeing this at hand. Bottom line up front, global cannot access local, but local can access global. All right, enough of scope. Let's go ahead and move forward. Let's talk about print statements. So you're probably wondering, what's the use of print statements? Honestly, the only and real reason for a print statement that I've come to find is for, honestly, just debugging, right? Seeing what your code is doing. It allows you to visualize the data so you know what's happening and where it's happening. Sometimes, especially if you have a long piece of code, maybe like a long function, maybe like 20, 30 lines, and it's not running right, it can be very difficult to figure out where in your code it's happening. And then the best tip to fixing your code or figuring out where it's going wrong is to add print statements at different parts of your code. And usually what that allows you to do is, let's say, for example, there was an error on line 2. right? Which call it, yeah. Let's say there's an error at line 2. If there's an error here, it'll probably won't run the rest, so we'll never see this line where it says result after the other step ever be printed out because it probably failed here, right? And that'll allow us to know, right? Maybe that's not a good example. Let's say here. Let's say our code failed here. We never got to print anything out here. We never got to the if product less than 55. But we were able to see this. What that tells me is that somewhere after this print statement, it failed, right? Probably right afterwards. All right, so print statements allow you to see that. We see here we have product X times Y. After that happens, I'm printing out the product, so I know, hey, my math works. I can visualize the response. I know it's supposed to do that. -2 times 30 is -60. So I know, all right, cool. Up to this part of my code, this is working. I then use a method called ABS, which stands for absolute. Essentially, what absolute does is it returns the absolute value of an integer regardless of it being negative or positive. And honestly, it's more of just negative. So technically, product was -6, but when I ran the ABS on it, it made it into a +6. So that's all that's doing. It made it into a positive integer and it reassigned it to product. And then I print it out again and I see it being printed out as well as the results. That allowed me to visualize, okay, up to this part of code, my code is still working, right? It's doing everything I needed to do. And then I get here where I say if product is less than 55, I should print out does not meet threshold, else I should print out meets threshold. And I see that it prints out meets threshold 60. I'm sorry, meets threshold right here. 60 is less than 55. So this is what it should have been printed out. So it allows me to visualize every step of my code to know that it's working. You don't always want to do this when you're coding, but it comes in handy when you want to ensure that your code is working. Sometimes it's good to, as you're coding, instead of just writing 25 or 30 lines of code nonstop, it's good to run it every so often to ensure everything that you've written up to that point is still working as intended. So print statements are a great way of doing that. Do I have any questions about when to use print statements? Awesome. I think that was pretty straightforward. Now, here we have an example. The print statement helps monitor the progress of complex calculation. So you're going to write your own function that determines what letter grade prints out when called with a numeric grade as a parameter. And you kind of saw Tristan already gave you guys that. I don't know if you knew about this exercise, but you're more than welcome to try this out. Essentially, as you see here, letter grade, the function letter grade, it takes in an integer and it returns the string of C. When it had the integer 96, it returned A, right? So essentially, 90 to 100 is an A, 80 to 89 is a B, and so on and so forth. I think nowadays they changed that grading scheme. I don't think it's the same, but that's gonna be the assignment for this one. Good job, Tristan. It's okay. So we're gonna go ahead and try this one. And then we also have some other assignments, which we'll give them a try and then talk about it. At first glance, this looks very confusing and you don't know what it's asking from you. So I'm going to talk a little bit about it. In short, none of this code actually really matters, right? The intent is to add something into these lines of code that will essentially pass and work into the following. For example, we see here we have an if block, but there's nothing here. But something should happen so we can go into this block of code, right? To do this. And if not, it should return this. Well, what you're going to do is you're going to place the following variables, these right here, and the correct if, elif, or else statements to trigger the congrats message that's right here, that's nested within all these conditional statements. Real quick, just so I'll start you guys off so you have an idea of how this works. Looking at this right here, we have if, and then it's a colon. Which one of these variables could we add in here that could trigger a positive response to allow us to enter the code block? Let me get a verbal response. I want to hear some interaction. All right, Nicholas, thank you for that. Yeah, maybe var 1, right? We can say if var 1, which is true, if true, which it will, right? It'll go into this code block, right? So that'll definitely pass. And now that brings us into here. Where's that? Right here. Okay. So the next check, we're saying if there's something missing is greater than 33, what can we add in here to make sure this passes? Yeah, var 5 will work just as well. We could add var 5. We can say if var 5, and technically that will pass. If var 5, which is 65, is greater than 33, then I should do the following. Next, we see if type is equal to int, then we print wrong way, right? Else, we print end at 3. So notice that we're trying to get to the print statement of congrats. So what does that tell me about that? If I pass this check, it's going to come down here and this won't work. I won't ever get to here. Because if this runs, what does that mean about this block right here? It means it doesn't work, right? If for whatever reason this line of code passes, I won't get to the elif statement that's at this piece of code. So I'll never get to the congrats. So I probably don't want to ensure that this part of this code passes a check. Because if it passes a check, I will come in here and I won't ever get to the congrats message. So maybe add something that does not pass the 33, like maybe var 6, right? Var 6 is 25. So that means that it's not greater than 33. So I would not come into this line of code. So that means this if statement fails, which brings me into this part. Now you're probably wondering, Roger, this is very confusing. There's like so many lines of code. Where does it start and end? Well, let's look at it. This if statement, where's the else statement for this one? Well, you can use the line that's connected to it. Everything that's within this code block is past this line. If we scroll down, after that if statement, we have this else statement. So if this doesn't pass, then we would go into this else statement. So it did pass. So we come in here into this if statement. Well, where is the code block for that? It is all of this, right? Because we have if right here, and then we follow this line. After that if, we have the next elif. And then if we follow that elif, the next part is else, right? So that's how the indentation works, right? And then for the next one, we see here if and else. These two are in the same code block, right? So that's how you can follow what is within what. It might look a little intimidating. It's just taking a little step, step by step and trying to dissect where the code starts and ends. But going back to this code, so Awesome. We made sure that this if statement does not pass. That way we do not come in here because we were trying to reach the congrats statement, right? So because it does not pass, it brought us in to the elif. And then we are within right here. This is the elif we're in. And this is where we want to be, right? We don't want to fail this check right here because if we fail this one, it's going to resort to the else statement right here. So we want to ensure that we pass this elif statement. What can we add in here to ensure that we pass this check? I see bar 5 and bar 6. All right, bar 5 is definitely greater than 20, so we could definitely add bar 5. That'll pass. And then we have to choose something that's less than 30, which is bar 6. So we can say and bar 6 is less than 30. This will ensure that this elif statement passes. So now it brings us to this code block right here. So we have to ensure that we pass this if statement so it does not resort to returning and at 4. Right, and then so on and so forth. We want to keep doing that until we reach the print statement of congrats, utilizing these variables. This is one out of, I believe there's a couple, 4 or 5 assignments, right? We're gonna take 10 minutes to do, actually we'll do 5. We'll do 5 minutes for each. And then we'll take a demonstration. So let me solve this one. Actually, we can continue. Since I already did most of it. We get here, we want to check something that equals to 85. So what can we add to 20 to equal 45 or 85? We can do var 5, which is 65 plus 20 will give you 85. So that makes sure this passes. And then here we say if not, or we can say var 2, if not false, and then if it's not false, then we will go into this code, which now brings us here. If greeting is equal to 11, which honestly, this should work now, I think. If we run this, we get end at 7. Okay. If greeting is equal to hello, then this will work because greeting is equal to hello, right? Greeting is hello, so this will pass, which brings us here. The len is a length method. Whenever you pass something in here, it's going to grab the length of that item, and we're comparing the length of it to 4. So what within here is equal to 4 in length that can pass this? Well, I see var 3, which is the string hello. That's 1, 2, 3, 4, 5. Oh, that's 5 characters. We have here this list called var 8, which has the word this, and it has 4 characters in here. So we can say if length of var 8 at index 1 is equal to 4, and this is not working. Oh, because we have to call this right here, var 7. This is a dictionary. This is a little out of scope. So I'll do this for you. We're going to call the dictionary. And very similar to how we grab items that list using bracket notation, right? Just like we did here, we're grabbing the item at index 1 in this list to access items in a dictionary. And I do apologize, this is a little out of scope, but we use the brackets and then the key of different items within this dictionary. We have here var 7 at key of greeting is equal to hello. And now we have congrats. Do I have any questions before we take the next 5 minutes to work on this? If you guys have any questions about this dictionary part, maybe this one isn't the best example. I'll make sure I update this since we have yet to get it into dictionaries. But just know if you want to access something within a dictionary, you have to call the dictionary name. Very similar to how we call the list name. And you open and close some square brackets and pass in the key value pair. The way that this works is that dictionaries have key values where, for example, this is one pair right here, and the pair is separated by this colon here, where the key is greeting and the value is hello. That's one pair, right? And then we have a comma here to separate the next pair, where we have a key of age and a value of 33. That's a little crash course of it real quick, but we'll talk a little bit more in depth into dictionaries at a later date. Time is 8:36. Go ahead and take until 8:31. Yes, Morty, it is actually an object, very similar to JavaScript, but it's called something different in Python. The objects in JavaScript are not exactly the same as objects in Python, and we can elaborate a little bit more later on. But you are correct. You essentially access them pretty similar. There are actually key distinctions to it. We call them dictionaries here in Python, but good guess, good guess. All right, 8:37. Let's go ahead and come back at 8:42, and we will take a volunteer to show us their code for assignment 2. Give it a try. All right, let's get a volunteer. Somebody, anybody, come one, come all. All right, guys, let's not be shy. All right, Nicholas, let's see it. Go ahead and share your screen and kind of talk us through the thought process and how you worked it out, if you could.
All right. Mm, can you hear me?
Yes, we can. Take us
Okay.
line by line and why you chose what you chose.
So we started here. I chose var2 because we had to make it into or we had to not make it into this code block here. Um yeah, which makes it true. So I did go in here. Hold on. Now I'm lost myself.
Run it just in case.
It runs right. I got it. I got it good here.
Yeah, so let's go back up to it. It passes that, right? It did pass the check, right? That's what we use true. Because what's the alternative of that passing? If that doesn't pass, where would it
Because
go?
if it doesn't pass, I go way down here to end at 7.
Correct. Yes, sir.
So I needed to go in there. I didn't need to go into this one here.
Correct.
So I needed this one to fail, so I chose 6, which was less than 35 instead of greater. I didn't need to fill anything in here because I didn't need to go in there. Uh, so then it brings us down here, which you had just showed us before that. So I had to go into the um forgot the
We call it a dictionary in Python.
yes, so into the dictionary to get the age out of there so that we had something that was less than or equal to 25. Um,
Right on.
and then modulus of 2, we had to have 0, so it had to be an even number. So I picked 5. We could have picked 4 or 6 as well. Um, and then this one, so for it to pass, it had to not be true or not be false, which then makes it true so that we can go into this next block. And then I used the greeting for variable 7. It's saying it's not hola, which it's not. It's hello, which here. And then the length of variable 3 is the 4 letters, and which then gets us to print congrats.
Awesome. Good stuff, man. I appreciate it. Thank you for sharing your screen.
Yep.
All right, so you guys saw me do it myself, and then you got an example with Nicholas. Thank you, Nicholas, for that demonstration. I hope more people try to jump up and volunteer. If you guys move forward with this program, that's going to become a regular thing. Showing your code and demonstrating, even if your code is absolutely dead wrong, that's okay. It's good to kind of make mistakes, and then we, as a group, can talk through your code and figure out like the thought process. Right? It's good to have multiple eyes look at your code and stuff, and also just demonstrate it. You're gonna be expected to talk through your code and understand what it is, especially right now too. Kind of get used to it, because that's what your assessment, your technical assessment with Guillermo is gonna look like. Right? He's gonna give you a problem, and you're gonna have to solve it in code in front of him with your shared screen and talk through what you are doing as you code through it. Right? Demonstrating that what you're coding in there, and you're not just pulling this out of nowhere. Right? So I highly encourage you guys be a little bit more excited to try share code, get that reps in, so you feel a little bit more comfortable when it comes to your technical assessment with Guillermo. We're gonna go ahead and move forward from here. You do have the rest of the assignments to you guys to try it out on your own. Obviously, they're nothing crazy, right? It's kind of just getting used to comparing stuff and using if else, and also just kind of getting used to how these cell blocks work, the indentations, and whatnot. Right. This is a good practice. Like I said, it looked a little overwhelming a little bit, but as we broke it down step by step, it became a little bit more digestible. I did add some new exercises here. Nothing too complex. There is not as much as there was yesterday. And then I want to say 2 or 3 function exercises that you can use, like reversing a string in a function, counting the number of times a vowel or vowels are within a string, not using a for loop because we haven't talked about for loops. So you can do this without a for loop. You just have to be a little crafty with it. And then also maybe taking in a temperature and then converting it to, Celsius to Fahrenheit or Fahrenheit to Celsius within a function. So you have these. Use everything that you guys learned today to kind of work through these. You're going to notice that some of these are not too complex, guys. I understand we do have, a large class. There's like 30 some of y'all. Well, there was 39, actually I think like 42 yesterday. We have some 29 today. Some people might not be here because of scheduling, or they might have left before we started the assignments because they thought the curriculum was over, which is fine. But we do have people from all ways of life at different levels. So if you feel like these are too simple for you, that's fine. I would definitely go and resource somewhere else. Just know that we're not looking for you guys to be subject matter experts. Just really understand the fundamentals. And the reason for that is because, sure, you can get very complex for your code, but at the end of the day, you can honestly just solve most of the problems that you have with just declaring variables, adding some if-else statements, and then using some like for loop logic, which we'll figure out later in the course. It's very simple, code, and that's honestly all that's expected from you guys. Just understand the fundamentals of coding, what variables are, the types of data structures there is in there, the data types, and just being able to problem solve. That's what we're looking for, you guys. So if you feel if this is a little too easy, that's fine. Utilize the resources that are within the pre-course. I believe that's where it was. If you scroll to the bottom, you can find other stuff like video tutorials, I was asked about other places to learn. You have, Free Code Camp, Khan Academy. If this is a little too easy for you, you guys can check that stuff out. We have Automate the Boring Stuff with Python. This is, I believe this is the book itself. Yeah, here we go. You have access to the book. So if you need another example of how stuff works, you guys can come here and check out like functions, right? And they can break it down in a different way that maybe I couldn't for you guys. So, we all learn differently, a little bit more visual, or maybe just the way that I teach to you guys wasn't, very good for you. So here's other versions that you can use. So definitely check out those stuff. I get Peter, can you drop the link? I definitely can for this book. I get asked a lot about, the link or the location and stuff. Once again, to reiterate, the location of our curriculum is going to be located within the Slack channel. At the very top, we have the bookmarks tab. You can find the curriculum repo here, which will bring you to the repo of our lessons, right? Click on lessons. And here we have everything that I've been covering. You go to pre-course and find what I just showed you guys here at the very bottom. You can find all those links. I see, Peter, I don't have access to bookmark, or it doesn't show up for me. Okay, we can figure out what's going on with that in a bit. But let me drop the link to the curriculum for those of you guys that do not have access to it right now. That'll take you there. Stack Overflow. If you guys are still learning JavaScript, you want to continue that, you can learn JavaScript. But there is other resources, and that stuff's too easy for y'all. I just want to make sure that everyone has something to work on besides just wondering what they should be doing. And honestly, as long as if you guys can complete this stuff, you can understand what we covered. You guys should be solid. Do I have any questions about what was covered today? Anything at all?
I mean, for me, I feel like it's more so just maybe practicing, it seems like rocket science from the very beginning, but practicing definitely will help.
Yeah, for sure. I recommend do all the assignments. I am updating, guys, the curriculum as it goes. Quick disclaimer, right? I was not the previous instructor for this course. It was Aaron Wood. Unfortunately, due to demands from his day job, he wasn't able to continue teaching the class. So I essentially adopted the curriculum, and I am slowly adding to it stuff that I think will be beneficial to y'all. You guys are the first class to have like additional lesson exercises like this. And I'm essentially creating these as the days go to ensure that you all have some additional material if what was being taught is not enough. So because of that, if you want the most updated version of the lessons by the next class, you have to essentially recreate that code space and open it up. So before that next class, I recommend just do those exercises. I don't believe these exercises should take more than 30 minutes for the simple stuff. The functions, it is brand new, and functions are a little bit more complicated than, maybe like a creating a Boolean or a comparison. This might take a little bit longer, but it should be maybe 30 minutes on average for the exercises, and that should be enough to guys get you started. I'm gonna go ahead and stop the recording here.